All right, let's now talk about something called the Jahn-Teller effect. And we start, as we have uh, for most things we've been talking about, when we have six ligands with an octahedral arrangement. But we'll see that in some cases, um, there is a rearrangement of the geometry to lower the energy. And so let's first, as we have often, sketch in our octahedral levels, so the EG set and the T2G set. And this time, let's go ahead and also put our labels for individual orbitals. So z squared, x squared minus y squared, xz, yz, and xy. And first, let's look at an axial compression. We'll go and do the one here on the left. So we're taking these two bonds that I've marked here in red, and we're going to compress them. So in the original structure here, they're all the same length. We go and we squeeze those down to compress just these two ligands in toward the metal, and let's see what happens. And part of what happens here is going to be similar to what we saw when we were, or similar thinking to what we used when we looked at square planar, except we go in and we squeeze the the orbitals along the z-axis. And when we do that, anything with a z component goes up in energy. So the z squared goes up in energy, the xz and yz go up a little bit in energy. This goes up quite a bit more. And then anything without a z component goes down in energy. So xy and x squared minus y squared goes down in energy. And why might we want to do this? Well, this would be a better energetic structure. For example, if we had a D1 electron configuration. By doing this axial compression, we've put 4 orbitals up in energy, and we have lowered 1. And so this is energetically a good thing for us to do. And so this 1 electron goes down, and the empty orbitals don't count against us, so we get to bring this 1 electron down, and so we're happy about that. Well, there's another case that can occur here, and that is an axial elongation, and this is going to be more similar to deriving the square planar orbital levels. So we go in and we pull along the z-axis. So pull along the z-axis, the two, but not completely off, just pull them off, just tug them off a further distance from the metal. And when we do that, anything with a z component goes down in energy, and anything without a z component goes up in energy. Anything without a z component goes up in energy. Anything with a z component goes down in energy. Okay, and so we get levels that, that are split out like the square planar levels. Not as much, but there's some shift that goes on. And so if we had a D2 electron configuration, this would be a better arrangement to put these other orbitals to drive some of them up in energy, but to drive these two down, and so our 2 electrons now have a home that's lower in energy. And so a D2 will prefer an axially elongated octahedron. A D1 will prefer axially compressed octahedral configuration.